Okay guys, we're just going to do a really quick video on topic 6, which is the introduction to proofs. This whole unit about logic has been preparing us to do this, and the purpose of proofs is to take something that we already know to be true and proving something new. But the big important thing about proofs is for every single step that we do to get us from point A to point B, we have to give a reason for why we can do that. So we're using a series of things that we already know to be true to create a new conclusion. Kind of what we did with the law of detachment of the law of syllogism. We used conditional statements and things that we knew to create a new conclusion or something else that we knew to be true because of the law of detachment or because of the law of syllogism. So here's the first example. This is going to be 6C. You don't have to copy these notes. We just want you to watch. We're going to practice these in class together. But if you ever want to go back, this will be here for you to go back and look at. The first thing we're going to do is an algebraic proof because we know, I feel most of us understand algebra pretty well and understand our statements. We're just going to go in and put the reasons. So a proof has two parts. It has the statement side. This is called a two-column proof or a T-chart. This side is our statements. It's where we show our algebraic work. This side is where we give the reasons for why we can do each step. So if we look at this first step, how do we know that we can put this here? Well, that's what we were started with. That's what was given to us. So my reason for being able to write that is it was given to us. Well, if I need to solve for x, which is eventually what we're going to do, the first thing I'm going to do is distribute this 3 to the x and the 3. And we've always done that because we know that's what we do when we see a number in front of the parentheses. But the reason why I can do that and why this statement has the same exact value or meaning as this one is because of the distributive property. So distributive property. Good. Okay, well we know when we're solving, we want to get all of our x's on one side. So I'm going to move this minus x by adding x to both sides. Well, I can add something to both sides of my equal sign and get something that's still true because of the addition property of equality. We're just going to call it the addition POE, but that stands for the addition property of equality, and we use that word equality because of that equal sign there, but we're just going to leave it like that for now. Okay, so we've added x to both sides. Now we need to subtract 9 from this side so the x's are by themselves. So we subtract 9, and this has the same value. This is still valid, it's true, because of the subtraction property of equality. That's the reason I could do that last step to get me to here. Well, now we need to divide both sides by 4 to get x by itself. Surprise, surprise, that's our division property of equality. Now, you might have in the past just flipped it at the end to x equals 2, but we have to give a reason for every single thing that we do. And the reason I can go from 2 equals x to x equals 2 is because of the symmetric property of equality. Some of these properties you've seen before, and some of them you might not have, and that's okay. And in class, we're going to go through all of these properties and make a list of the properties we can use for algebraic proofs. Now, we use this as a starting block because most of us understand all of the statements for the algebra portion. Well, in a geometry class, we need to prove new geometric statements. So in this picture, we have two straight lines that intersect, and we have angles 1, angle 2, and angle 3. Now, we already know that angle 1 and angle 3 are the same size. That's what we're trying to prove. It actually has a name. It's called the vertical angles theorem. That's why these two angles are definitely congruent. However, theorems have to be proved before we can use them. And so I'm going to prove to you why vertical angles are always congruent. So most of the time, we're going to give you a list of statements. You just have to write the reasons. But for those of you in an honors, you're eventually going to have to get to a point where you're writing all of these statements. So, well, for regular, you might have to write some of these statements. So let's get started. We're given this picture. We need to prove that angle 1 and angle 3 are congruent. So the first statement I have here says the measure of angle 1 plus the measure of angle 2 equals 180 degrees. Well, let's look. Here's angle 1, here's angle 2. Their measures add up to 180. Well, we know that. They're a linear pair. So we can say that these two things, this is true, that measure of angle 1 plus the measure of angle 2 equals 180 because of the linear pair postulate. And we'll talk about what the linear pair postulate is next class. We're just going to use it for now. But that's my reason for why I can do that. The difference between this step and this step is I've subtracted the measure of angle 2 on both sides. I moved it here. And just like we did in the algebraic proof, we're going to use the subtraction property of equality. Okay. Now I have something totally new. Here's angle 2 and angle 3. The measure of angle 2 plus the measure of angle 3 equals 180. Well, that's the linear pair postulate again. We know that two angles in a linear pair, their measures add up to 180 degrees. So there's my linear pair postulate. Postulates are kind of like theorems, but they don't need to be proved to be used, and we'll talk about that next class. Okay, for our next step, you'll notice the measure of angle 2 moved to the other side again. We subtracted on this side and this side. So here is my subtraction property of equality. Hi. Okay, we've got 2 more steps to do. So you'll notice now we have that the measure of angle 1 equals 180 minus the measure of angle 2. And here the measure of angle 3 equals 180 minus the measure of angle 2. Since both of these things equal the same thing, we can use the transitive property, which says that this thing has to equal this because they both equal the same thing. So that's my transitive property of equality. My last step is to show that angle 1 is congruent to angle 3. Well, since their measures are equal, we can use the definition of congruence to state that because their measures are equal, their angles are going to be congruent. So that's how proofs work. It's when we have a list of statements, but now we have to give a reason for why we can do each statement. And we're going to practice this in class. This is just an introduction. Remember, you don't have to take notes on this, but for those of you who have watched this video, on your unit plan, go ahead in the top left corner, write the name of your favorite professional sports team. And we'll see you guys in class tomorrow.